Hello students, in this video we are going to learn about some applications of refraction. We have learnt about refractions, laws of refraction, and how it happens. So let us learn what are the applications. There are various applications, but today we will be concentrating only on two or three. Okay, so first one is, now suppose if there is a container and in that container you fill with some liquid. Okay, correct. Now this liquid has, suppose, refractive index as n1. Okay, or same case, suppose on a table. Okay, one more thing, let us put a coin here. Okay, at the bottom. Okay, similarly, if you keep a table here and a coin is there, and on that coin if you put a glass slab. Okay, here we have put a liquid, here we have put a glass slab on a coin. Okay, now see what it happens. This is my depth. If you see about this inside the liquid, this is known as my real depth. Okay, understand the terms, real depth. Similarly, this, the whole thickness of the slab, is my real depth. Now what happens? we will be watching this coin from upside. Okay, so to get an image of this coin, what will happen? One ray will travel normal and it will go undeviated, right? This is my denser medium and this is my rarer medium, right? And now one more ray, what I will do, I will make like this. Okay, and it will go, if you draw a normal here, it will just go away from it, right? Similarly, we can draw here also one ray which will be normal and one ray it will go away, correct? Now if you just draw this ray backward, this is the point where you get the image of this coin, because we are watching from outside. So these two rays will reach to our eyes and these two rays are coming from this point, so we will be getting our object's image here, correct? Right, similarly you can draw the ray here also, so you will get to see the coin at that point, correct? Now this depth, is called as my apparent depth. So understand the terms, real depth and another one is apparent depth, right? Okay, real depth and apparent depth. And what is this? The shift. Here also the apparent depth is what? Just making it clear, right? This is my apparent depth. Now real depth and apparent depth, they have a relationship. What is that? We have like real depth upon apparent depth is what? A refractive index of medium. Which medium? Which we are putting it, right? Like slab here, glass slab, or water here. So refractive index of that medium. Real depth upon apparent depth, right? Now what is this? The shift. Suppose this is my x. My coin has moved upward. Here also my coin has moved upward. This x is basically known as my shift, or in some books you get it like normal displacement. Normal displacement, right? So what is the formula for this? If you want to calculate this x, so x is equal to basically real depth minus apparent depth. This whole depth minus apparent depth, you will get the x. Now if you just put, suppose this is my n1, okay, so if you just write, we know the RD is what? The thickness of the slab or the real depth of the water. So I am putting everything in terms of RD. So RD minus, what is AD here from? If you take AD will be, it is RD by N1. So let us write RD by N1, and if you take it as common, you will get 1 minus 1 by N1. Remember this formula and this formula also. Right? Real depth upon apparent depth is refractive index of medium, and what is this? This is known as my shift or normal displacement. Formula for this is real depth multiplied by 1 minus 1 upon N1. Okay, so what happens basically, what the coin moves, the image of the coin moves upward. We will be able to see the coin at a lower depth, right? So if you observe this thing, when you put your legs in the water, it appears that the legs become shorter, right? Why? Because when you put your legs at the bottom of this and your legs appear like it has moved upward, so your length of the leg inside the water will become shorter, and hence your legs also looks shorter. So lots of application for this thing. If you keep anything inside the slab, suppose if you write something and keep it at the bottom of the piece, here the letters appears at the midway on the slab. Okay, so this is one application. Now we will understand the factors affecting the shift. Okay, let us understand how the formula, which is what RD upon AD is N, or refractive index of the medium. Let us derive this formula first. Okay, so if you look at this whole arrangement again, this is my coin, this is my image, and we are looking from outside. Okay, so this is what angle of incidence. I have drawn normal here. Okay, if this is angle I, this is also angle I, alternate angles. Similarly, if this is angle R, this angle is also R, corresponding angles. Okay, because these two lines are parallel to each other. Why? Because they are normal to the surfaces. Okay, now this in triangle ABO. Okay, if I write sin I will be what? Perpendicular, which is AB upon BO. BO is what? Hypotenuse. Okay, now see, basically we will be looking from the top, and this point B will be very close to A. This is our assumption. Okay, so B is very close to A, hence this BO will be equivalent to AO. So we can write as AB upon BO is what? AO. Okay, similarly in triangle ABI we have sin R. Sin R will be AB upon BI, and same condition applies for BI also. BI will be similar to AI. So I just replaced BO by AO and BI by AI. Now if you calculate sin I by sin r, or applying Snell's law will be what? If n is my refractive index of this medium, we can write n sin I is equal to 1 air sin r, correct? And then we can n into sin I is what? AB upon AO, and sin r is AB upon AI. Your AB can be cancelled here, so you will get n as AO upon AI. Now what is your AO? AO is real depth and AI is apparent depth. So here our formula, real depth upon apparent depth, is refractive index of the medium. Okay, now we will learn about how the shift is. Shift means what? Our normal displacement. Okay. Right. This is my apparent depth. This is my real depth, and this is my shift. How that shift is dependent on other factors. So what all factors which will affect my shift? We know the formula. Shift is equal to what? Real depth 1 minus 1 upon n. N is what? The refractive index of this medium. Correct? Now, see, definitely shift is dependence on what? Real depth. So if more the real depth, the shift will be more. It means if you just draw like this, if the coin is here, it may appear the shift will be more in this case and lesser in this case. Correct? So shift is directly proportional to my real depth. Similarly, shift is directly proportional to the refractive index also. How? Means what? More the refractive index, more will be the shift. Understand this. If you get higher refractive index means lower value of 1 by n. If n is high, 1 by n will be low, the reciprocal. Okay? And 1 minus 1 by n will be high, because you will be subtracting a lower number, correct, from 1. So hence the shift, the more the n, value of n, shift will be larger, right? So shift is directly proportional to n, and definitely shift is also proportional to wavelength, or you can say color. Shift is proportional to wavelength and color. See, for red the shift is very small, and for violet the shift is very much high. That's why we use red lights for danger. Red lights, yellow light, because the shift is very small. Okay. Okay, let's talk about another application of refraction. Okay, suppose there is a bucket or container, okay, which has some liquid here, and suppose there is some liquid, okay, and if you put a stick like this, okay, then what will happen? The stick looks a little bent. Okay, so this bending of stick is because of refraction. How it appears? Just understand this. What I am doing, I am making an image of this last point. Okay, let us draw two rays. Correct? And if you draw a normal at both the points, what will happen? This ray will move away, and then if you take these rays backward, it will look like the image will be here, right? So if you draw the image of all the points, okay, which is under the water or under the liquid, then what will happen? The points will be like this. So if you join the dots, join the image, the stick looks like a little bent upwards, okay? So this bending of stick is also because of refraction, right? So this is another application. Now we will talk about two important natural phenomena which happens due to refraction. One is a very little old poem, okay, the Twinkle Twinkle Little Star. It means what? The twinkling of star. How it happens, okay? Suppose my star is here, right, and I am on this earth, okay? So I am looking at the star, means light is traveling from star to earth. Now while traveling, what happens? There are lots of gases in space, correct? So there will be lots of gases, lots of dust particles also in space, and light travels through that area. So what will happen if I just draw a layer, different layers, correct? So what will happen? Light is traveling like this, and we have just learned that while if a light pass through a glass slab, what happens? The lateral shifting happens, right? So it comes parallel, but a little shift in displacement. So similarly, what will happen? Light will come like this. It will be parallel to each other, but will be shifting the positions, right? And due to these shifts, my star sometimes will look here or here. So it will keep on shifting the positions, and because of which the star looks like twinkling. So what is the meaning of twinkling? Changing of position, very little, right? So it appears like it is here only, but just towards right, towards left, towards right, so it is just moving and disappearing. So suppose sometimes it was here, and then in the next moment it looks like it is here, next moment it looks like here. So it will be on in a small area only, but not at fixed position, and it looks like it is twinkling, okay? So this is all because of refraction at different layers, right? Now another phenomenon is what? In the morning when we are looking at the sun, actually the sun has not risen, okay? So how it happens that the sun is here, suppose, and suppose we are here, this is my earth, and this light, direct light, if you just draw, it will be like this. So right now it has not reached our eyes, so we will not be able to see the sun. But practically what happens when light enters, these are the different layers of atmosphere at different temperatures. See, so the temperature, what happens with temperature? With increase in temperature, my refractive index decreases. With increase in temperature, my refractive index decreases. So what will happen? Earlier it is traveling, suppose in vacuum, okay, and it enters the atmosphere. So at this point what will happen? It will move towards the normal, correct? Now at this layer since the two layers have different temperatures, the temperature of the layer which is close to Earth is higher than the temperature of the layer which is far away. So this medium is basically what? A rarer medium, and this is what? Denser medium. I have just made only two layers to explain you. You can make lots of layers and multiple refraction will take place. So now at this point what will happen? If you draw normal, it will move away. Correct? Now this is light is reaching my eyes. So I can now see the sun. Correct? So due to refraction, what has happened? The light which was not supposed to come to us, it has bent and it is coming to us. So in the morning, when the sun is actually not rising, we can see the sun. Okay. Similarly, while in the evening, while sun is moving down, okay, it has not gone down, or it has gone down actually, but we can still see the sun. Right. So sun is suppose here, and we should not be able to see the sun, but due to refraction, we can see the sun. Right. The sun has actually gone down, but still we are able to see the sun. So if you just observe the things in the evening, you can suppose this is the horizon and you are able to see the sun like this. In the next moment, the sun just disappears. You will never be able to find sun like this. Why? Because actually when you are looking at sun at this position, the actual position of the sun is like this. So next moment it will go down, the complete will go in the horizon and will not be able to see. So suddenly from this point to this point.